And for the Laplace transform of a trigonometric function cosine, we have x of t equals cosine bt u of t, where u of t step function is equal to 1. So we have the Laplace transform of cosine bt u of t is equal to the improper integral of cosine bt u of t times e raised to negative st t. And again, since we have two different terms in our integral operation, we will have integration by parts as an integration technique. And again, we will use the tic-tac-toe method, having the derivative and integral. And we have the derivative of this as cosine bt, and the integral of this as e raised to negative st with respect to dt. And evaluating our derivative, the derivative of our cosine is negative sine. And since we have evaluated this with respect to dt, our b will be constant. So we will be having negative b sine, having the function here, negative b sine bt. And evaluating our integral part, we have negative 1 over s times e raised to negative st. And evaluating another integral, we have positive 1 over s squared e raised to negative st. And performing the matching of our method, the end method, or the tabular method, we will multiply each term, having form cosine bt times negative 1 over s e raised to negative st, and having the sign convention of positive and negative here. So we'll be having cosine bt, negative cosine bt, e raised to negative st over s, and since we have a double negative, or it has both negative, we'll have positive b sine bt e raised to negative st over s squared, having the limits of 0 to positive infinity. And evaluating this part, we'll be having 0 minus 1 times 1 over s times 1 plus 0. And transform or simplifying the terms from the limits, we'll be having 1 over s over s squared plus b squared over s squared is equal to, simplifying this term by the algebra, by laws of algebra, simplifying fractions, we'll have 1 over s times s squared over s squared plus b squared. Cancel this because of the exponents. So we'll have the Laplace transform of cosine bt u of t is equal to s over s squared plus b squared. So we have the Laplace transform of our function cosine bt u of t.